Dragzine CEO James Lawrence wanted to build a world-class supercharged Hemi. He called Eric Dillard, the owner of ProLINE Racing in Ball Ground, Georgia.
This Hemi that's in his car is our best cylinder head, our best everything that we have today is what James utilized in this build. We're going to start with a 136 blower, step it up to the 143 hopefully in testing this week, and just see where it takes us. I think we're going to have a competitive combination, but we'll know a lot more by the end of next week.
This week, the team is on the dyno. It's been more than a year since they began the project.
Well, anytime we dyno something new or a new combination, we'll start kind of slow, do some light pulls, keep the RPMs low. If for some reason there's something wrong, it makes it a lot easier to take care of things early. You'll catch things early. More stuff can go wrong as the RPMs go up and the power goes up. So for an engine like this, we'll warm the engine up for 5 or 10 minutes, put some heat in it. We'll let it heat soak for about a half an hour. And then when we start to make pulls, we'll go light, maybe 6,500 RPMs. Even though the engine's capable of a lot more, we'll do a light pull to make sure the map looks good, plugs look good, nothing leaks, nothing's out of place. And this gives us an opportunity to make sure everything's good before we run the RPMs up and run the power up.
FuelTech, we met those guys back in 2011 or 12. The relationship between our two companies is very strong. You know, we're out here dynoing today, and you know, Anderson and all the tech guys from FuelTech are here and helping us on the dyno, and it's become an extremely strong relationship, and we just want to see it grow and be able to offer that to all the other companies out there that want to work with FuelTech, because it's a combination that, man, it's just hard to beat.
My name is Anderson Dick. I'm from FuelTech. I'm here to talk about this very nice project of V8, over 3,000 horsepower, alcohol engine with all FuelTech products. The FT600 is a good fit for pretty much every drag racing application. In this particular case, the Supercharger alcohol engine takes a lot of fuel, and they're using all of those 16 injectors. And tuning-wise, is very important to have all the very advanced capabilities like individual cylinder trim for the 16 injectors. We can control both primary and secondary differently in different tables, so it makes much more capable of controlling the fuel over the engine. Pretty much what we're doing right now here in the dyno is figuring the tuning-wise what this engine likes and how to pretty much perfect the tuning of the engine. And that's where the controls of the FuelTech is very helpful. We've been working for a long time on this racing application, and pretty much is making a lot of difference in terms of delivering results and safety for the engine.
We do a bunch of different things inside one building. It's kind of broken us apart from a lot of the other engine builders in the industry. We've really worked on catering towards the tuning side, and we have a lot of guys that tune for us and are very loyal to us as a company, and we're very loyal to them. We've got our engine building business, which is what everybody knows us for. We sell a lot of parts, but not only do we sell parts, we do like turnkey packages. So we try to sell competitively with all the parts for the guys in the heads-up market, but we're really going after the guys that want to come to us and get that complete package to go out and run at the front of these heads-up classes. So ProMod, Radio Versa World, we're working on some LDR stuff now with this new Procharger front. you know, that's really where we succeed.
Hey guys, Chris Jones, shop manager here at ProLine Racing. I'm going to go over our Hemi 3,000 horsepower supercharged deal. Some of the components that we use in this thing, key features of it. Here we utilize a 10-225 deck height Hemi block from Allen Johnson Performance. It's based on the old TFX design. This is a billet iteration of that block. Most of the blocks used to be a forging. On the 3,000 horsepower build that we're discussing today, we use a P8 iteration port program from AJPE. It's a 2490 intake valve, 2020 exhaust valve, which is a bit unusual for an outlaw style cylinder head. Most of them typically will run a larger intake valve, a little bit smaller exhaust. We use a Bryant billet crankshaft. This is a larger wing design up here in the crank throws. It's a little bit heavier duty right here where the throw meets the main to add some strength. The other thing that we utilize on all of our engines is an 8 counterweight design. These tend to flex a lot less under duress and high power. We use Cleveite bearings, Vanderbilt style bearings, in almost all of our engines, 481s and Hemis especially. Our rods are actually pretty heavy duty. This is our normal Miller rod. We use Bill Miller rods almost exclusively. And this piston is utilized in different compression ratios, so different dome heights in basically all of our Hemi engines. So it's got a lot of reinforcement towards the bottom of the pin boss. This is a forging, of course. You can actually see where the machining is done and where the rough areas are for the forging itself. We use currently a Trend TP1 material pin. It's an 1.94 inch in diameter, which is slightly smaller than what you're going to see in a fuel car. We use total seal rings, again, in all of our engines. It's a Dykes configuration in the top ring, so it's a pressure backed ring. PDRA Pro Extreme kind of dictated that we needed to take as much weight out of our cars as possible, and in order to do so, we ditched the dry sump. Working with Moroso several years to get a pan design that works really well in the wet sump design now, and our latest iteration of these pans is great. Holds great oil pressure all the way down the track. We utilize an RCD gear drive on all of our engines. Gear drives are just the most reliable way to time your camshaft. You don't want to have to worry about belts jumping around. So this gear mounts to the camshaft itself. The cam itself is, in this instance, a competition cams tool steel piece. Suffice to say, it's a blower profile. It's fairly large in duration, wide lobe separation angle. We also use a Jezel lifter. So all of our engines utilize a bushed lifter bushing. Comp supplied us with springs in conjunction with the tool steel retainer. We typically will use a titanium retainer and titanium locks, kind of the normal deal. But the tool steel retainer here, you can see it's very light, comparatively speaking, and of course extremely strong because of the material. Ferrea valves, of course, in this particular engine, both titanium because it runs on alcohol. We don't have to worry about extremely high EGTs with alcohol. One of the other components that I don't have in hand right now, we actually have them in the engine currently, Trend push rods. So this particular engine utilizes a single piece push rod which actually has a tool steel insert in the cup end. This is our intake manifold, or rough approximation of it. Vizner actually works with us very closely on this. We went over several things when we started building our manifolds. One of the big things for our intake is a plenum, a large plenum volume, trying to get the air calmed down a little bit. So on the front of our Vizner billet manifold, we of course use a billet throttle body, which is provided to us by AccuFab. This particular unit is a 125 millimeter single. We use reed rockers on basically all of our Hemi engines. It's a billet steel rocker arm design. It runs on a shaft, oils here with a bronze bushing and a roller tip. So the atomizer injector that Jack provides us with, which these things are absolutely wonderful. These have been a godsend for us. We use an ATI, industry standard as far as balancers go. We've got the Mazir starter here. Been using these on all of our Hemi engines, and this particular piece is, of course, billet again. This is a Mazir billet flex plate. This particular unit is 136 tooth. As you can see, very, very heavy duty. This is NHRA, SFI approved, all that fun stuff. We use SCE for all of our head gaskets. They provide us with copper gaskets. Probably 98 to 99% of the hardware in this particular engine is ARP provided. And we use an Automotive Terminator billet pump. It's a 26 gallon per minute pump, so it's going to provide all the fuel that we could ever need. We use an Alston gear drive. The particular drives that we use are gear to gear. We use spline drive stuff on everything. We try not to use belts. We're in the infancy of our Supercharged program here at ProLine. We've learned a lot of lessons on what it takes to make great big power numbers, and when we use the ProCharger systems, we know we've overbuilt the engine. More power's on the docket and on the horizon. We're already eclipsing the 3,000 horsepower mark. We know we're going to start seeing 3,500 horsepower at some point in time. It's just going to be a matter of time before we get there.
The ProCharger stuff, I think it's almost like a whole new world for us.
The relationship between ProCharger and ProLine definitely is a big plus, not only to us to be able to test and develop even better superchargers, for ProLine to be able to test and develop better camshaft and cylinder head combinations that work with ProChargers, but ultimately it's the greatest for the racers out there. They're going to be able to reap the benefits of all this newfound power, newfound efficiency, and the combinations are going to keep getting better and better and faster and faster. And really that's what it's going to take to move the needle, to make more horsepower, to get the ProCharger cars out there running faster and faster every year. Right now we've got the F3R 136, which has been a tried and true supercharger for many years. That's what's on the blown Z06 engine behind me. That supercharger can definitely support some, like I said, 3,000 horsepower range. Depends on the engine combo as far as a boost number. That's a common question people ask, how much boost will it make? Of course it depends on the engine it's feeding into, but even on a big ProLine, Hemi like this engine where the heads flow, over 500 CFM, it'll still do upwards into the 40 pounds of boost range. We're always working on something bigger and better back at ProCharger, so there definitely will be something even more powerful than that coming soon.
You take a real car and try to make it into a race car. It takes time to build these cars. So we started with James, and then with that we created more relationships and we added a lot of combinations throughout the year, but a lot of these were full builds and getting built in cars, and now we're going to see all that stuff debut here first quarter of 2018.
3,000 is a good starting point, and it will actually make more than that in the car because you'll have air being forced in the supercharger that we can't recreate on the dyno.
The R&D for the bigger power is constantly evolving. This is part of it.
6,500 RPMs, it makes around 2,250 horsepower. 7,000 makes around 2,600. 7,500 makes around 2,900, and peaked around 3,000 at about 8,000 RPMs. Well, like I said, we can't recreate what happens in the race car. You have one in a race car, you typically have multiple gear changes. So the engine goes up and down through the RPM range at least once, if not a couple of times. We can't recreate the amount of air that goes in the supercharger, so the engine will make more boost at the track than it will here. So it's just a matter of not being able to copy the conditions in the race car exactly. So we don't get carried away trying to tune to the nth degree on the dyno because we know things will change when it goes in the car. The main thing is to give us a baseline and give us a good starting point.
We consider our dyno to be the racetrack.
Almost a year in the making, the team ran in the threes first weekend out.